again. Okay, so you probably just watched 12-3, or you didn't. But regardless, here is probability. This is 12-4. Okay, this is going to be our best friend. The definition of probability. If you're asked what is the probability of getting a head when I flip a quarter, okay, I want a heads versus a tails. Well, in order to figure that out, we take the number of ways to get a specific event. Well, how many ways can I get a head if I am flipping a coin? Well, one, right? But the total number of ways possible, so the total number of outcomes is 2. So the probability of me getting a heads instead of a tails is 1/2. Pretty basic, I know, but it's a good example. All right, P of A stands for the probability that an event, we're talking about A here, will happen. So the probability of us getting a heads would be P of H. For all probabilities, the probability that that event will actually happen is between 0 and 1. We consider that 0 not going to happen at all, and 1 absolutely it will happen. Okay, so 0 means that the event cannot happen, absolutely not. Like me just handing you an A in this class. Nope, not going to happen. But you working super hard to earn that A, absolutely that's going to happen. So I'd give that a probability of 1. Now, P of A with that line on top means the probability that the event will not happen. So what we have to do in order to find that is take 1, because that's certain to happen, right? So we take 1 and subtract the probability of it actually happening. So think of a circle, right? If I have, here's my absolutely it's going to happen. Well, that's a hole, and I find that my P of A is actually 25%. There's 25% that this is going to happen. Well, I'm going to take that away from my probability. What is the probability that it won't happen? What's left over? That's why we subtract it. And in this case, it's 75%. Okay, so those are some things that you need to memorize and love and learn. We also need to know the definition of odds, because they are 2 different things. The definition of odds is the number of successes over the number of failures. Okay? The number of failures is the total possible outcomes minus the number of successes. That may seem straightforward to you, but for some, maybe not so much. So let's say that I roll a die. Okay, there's 6 sides to a die. Let me pull up my paper over. That I'm going to roll a dice. And I want to know what's the probability that I'll get an even number. Well, on a die, I have a 1, a 2, a 3, a 4, a 5, and a 6. So I have 3 even numbers. Okay, so that's the number of successes over, well, that's what I want. What are the number of failures? 3 over 3. Okay, those are the odds. So, and usually odds are written as a ratio rather than a fraction. So in this case, I would say 3 to 3. All right, so let's do some math. We have this awesome chart about rolling 2 dice and the sums of those dice. Okay, sample or example number 1 says we roll 2 dice, and using the chart above, or the sample space, we need to find the probability that the sum of the dice is 4. All right, we're dealing with probability. So on top, I need to find the number of ways to get the event we want, which in this case is sum of 4. Well, I have 1, 2, 3 possibilities. So that goes in my numerator. I have 3 ways to get it. Well, how many ways or answers can I have total? If you count all of these up, you'll get the answer I'm about to tell you. Or I take one side, 1, 2, 3, 4, 5, 6, multiply it by the other side, 1, 2, 3, 4, 5, 6. I have 36 possible sums. If you can reduce it, please do. So in this case, the probability of you getting a sum of 4 is 1 in 12. And that's it. So what about sample 2? Same idea. We're going to roll 2 dice. We want to find the odds that the sum is 4. Okay, the odds. So now we want a ratio. It's the number of successes to the number of failures. Well, the number of successes is 1, 2, 3. We talked about that already. It is 3, 2. Well, I have 36 possible. 3 are what I want. Therefore, 33 is what I don't want. Okay, successes to failures. And I'm going to reduce it, so this is 1 in 11. It's 1 to 11 odds that the sum will be 4. What about sample 3? Okay, now they're getting a little crazy. I have a bag that contains 6 white, 3 blue, and 7 green marbles. We choose 1. We want to find the probability. Okay, so we're going to use this fraction up top. Find the probability that it is white. So I have the number of possible on top, there's 6 white ones, over the number of total. Well, 7 plus 3 plus 6 is going to give me 16. So I have 6 out of 16 chances to get a white marble. But I can reduce it, so really I have 3 chances out of 8. Okay, what about B? That the probability it is not white. Well, that would be 7 green and 3 blue marbles. So I have 10 marbles out of, my total doesn't change. And I can reduce this. So I have 5 out of 8 chances that it's not going to be white. Okay, the third part says, well, what are the odds? Okay, if I'm dealing with odds, that means I'm dealing with a ratio, and it's successes to failures. Okay, the odds that it is white, we want it to be white. Well, I have 6. What's left over? The 3 blue and the 7 green. So I have 6 to 10. And absolutely I can reduce this, so I have 3 to 5 chance that I'm going to get a white marble. Okay, so odds versus probability. Not too bad, I wouldn't think. What about number 4? We have a bag containing, again, 6 white, 3 blue, and 7 green marbles, but this time I'm choosing 2 marbles. I need to find the probability. Okay, so I'm going to do success over total. Find the probability that both marbles are blue. All right, well, I have 3 marbles out of 16. And it doesn't tell us we replace the marble. So we need to automatically assume that we take one and then we immediately take another one. So if I take one, that means there's 2 left out of 15. And we're going to multiply our chances because we don't know the order. Okay, well, I can reduce this 1 and 5. I can reduce that, becomes 1 and 8. So I have a probability of 1/40th that I will get 2 blue marbles. Not really looking in our favor there, friends. Okay, but what about the probability that the marbles are not both blue? So we don't want them to be blue. Well, I have 13, 7 and 6, 13 out of 16 times 12 out of 15. Okay, 6 white, 7 green, so that gives me 13. I have 16 total because I'm dealing with probability. I take one, so there's only going to be 12 left out of 15. From here, I can reduce a little bit. This becomes 3, that becomes 4. I'm left with 39 over 64. Okay, that's my probability that they are not both blue. What about the odds that they are both blue? Now I'm looking at successes over failures, okay? So I'm going to have 3, because I have 3 blue, over 13, because that's my failures, that's what's left over, times, well, if I take 1, I've only got 2 left, out of 12. Go ahead and cross-cancel for me a little bit, and we're left with 2 over 52, which reduces down to 1 over 26. Those are my odds. But remember, they don't want it written as a fraction. So we're going to write this as 1 to 26. That's my ratio. Now, what about the probability of getting 1 white and 1 blue? Okay, well, I have 6 white out of 13 total. And I have 3 blue, but I've taken 1 marble. Don't forget that. Okay? Oh, whoops. Back up. Goodness gracious. Okay, we're going to start over. If I have 1 white, right, that's 6. And, oh, it is probability. Oh, there we go, Miss Brady. Even on the video. So sorry, guys. 6 out of 13. Okay. Now, 3 blue out of, I've taken 1 marble, so I only have 12 left. Go ahead and cross-cancel for me. And I'm left with 3 over, did I mess up somewhere? I'm so sorry, you guys. Okay, let's fix our mistake. I say R because you're guilty with me. Okay. Not really sure what I was thinking. I think I was stuck in problem C. But we have 16 total. 7 plus 3 plus 6. And I'm sure some of you are thinking, duh, I knew that. But you know what? Just bear with me. Okay. So now we can cross cancel. This becomes 1. This becomes 5. This becomes 3. This becomes 8. And I'm left with 3 over 40. Whew, that looks a lot better. And since we're dealing with probability, we're going to leave it as a fraction. Okay, we don't need to put it into a ratio. Fantastic. Switch to the next page. And just for time constraints, I'm actually going to stop this video. We'll label it part 1. And part 2 will be examples 5, 6, 7, 8, and 9.